as we really have a close to the triangle congruency unit, we want to look at using all of these overlapping congruencies and being able to pick them out of figures to where we can talk about the corresponding parts of congruent triangles are going to be congruent. But using these congruencies, we want to be able to identify the triangle congruency theorem that can be used to prove two triangles are congruent, and then complete the steps to prove those angles, segments, and triangles are congruent using the triangle congruency theorems and the CPCTC, or the congruent parts of corresponding parts of congruent triangles are congruent. So just remember, as we look at this, congruent figures are going to be identical figures. Corresponding sides are going to be the sides in the same relationships along with the angles. And we'll look at some more examples of those. But I would say just remembering that we have side, side, side. We have side, angle, side. We have a hypotenuse leg. Let's see here. We have angle, side, angle, and our angle, side congruency theorems. And those are the things that we want to be able to use. So looking at examples, side, 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 of course, if I have a figure and I have, this is labeled LONM, and I can see that OL is congruent to LM and ON is congruent to NM. Well, I should also be able to tell that LN is congruent to LN, so therefore we have the triangle OLN is going to be congruent to triangle NLN. Okay, so just being able to look at that and say, oh, those, I can use my side, side, side to identify that those two triangles are going to be congruent. But just looking at this diagram, for example, is which congruency theorem can be used to prove that angle or triangle ABD is congruent to triangle DCA. And what I will do is I'm going to try and just say, hey, we have ABD is one of our triangles, right? ABD. And then we also have triangle DCA. So if I'm just going to try to pull it out here and say, okay, if I were to take this image and pull it off of the other image, I have angle ABD, or triangle ABD, and this is what I have available. And I will say that right here, AD is going to be congruent to AD, but give it a second, we'll see. If I pull out the other triangle, separating them, I am going to have a DC, and I'm trying to figure out here, are these two things going to be congruent? Well, I do have an angle. I do have an angle that is congruent, right? Or a length that is going to be congruent. I do have an angle which is going to be congruent because that is a 90-degree angle. And then I should be able to say that AD is going to be equal to AD. So technically I do have a side angle side congruency that would allow these two triangles to be congruent. So again, just trying to distinguish between the different congruency theorems and identifying what works. Now that is using side angle sine, but let's see if I identify another triangle here. And let's see here, I'm going to do this, 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 and this. And I'm going to say we're going to call this H, call this G, call this point L, point J, and point K. and we'll throw in some markings here that angle K is going to be congruent to angle G, and segment GH is going to be congruent to segment HK. And now I didn't just say I'm going to pick a theorem and make it work. What I'm identifying what I have. Well, I do have an angle in common, and I do have a side in common. And what I have then, my options, I'm looking at, I could have a side angle side, but I don't have any other congruencies here. You know, this side and this side, they don't tell me that those are equal. But hopefully you can recognize that you do have a vertical angle here, right? I have a vertical angle, so it looks like, yes, I do have some additional information here. So it looks like I have angle side angle congruency, and in that I have that triangle. It looks like GHL. So let's see here. GHL is going to be congruent to KHJ. So they are going to be congruent to triangle KHJ because of angle side angle. And again, it is just allowing us to, given an image, try to determine what congruency, if there is, that I can determine. And so here, if we have this image, and it looks like I have triangle BDA is congruent to triangle BDC. Yes or no? 50-50, right? No. I could be wrong, but 50-50 I could be right if I say yes. Let's see. So triangle BDA, is that going to be congruent to triangle BDC? Well, let's see here. I'm just going to separate them real quick. So I'm going to take, and I have triangle BDA. And then I'm going to turn around and say, well, I got triangle CDB or BDC. And the only thing that I can look at here is I do have two sides that are congruent. So do I have another side that's congruent? And I think I do, because BD should be congruent to BD. So therefore I have side congruency by looking at these two images. So again, using what I have, identifying what I have, and then seeing what is still available on the image for, to determine that congruency. So as we are using triangle congruency theorems, we want to just make sure, we have 5 to choose from: a side, angle, angle, side, the hypotenuse leg, and then the side congruencies. We use those to prove that triangles are congruent, and once two triangles are proven to be congruent, then you know that the corresponding parts of those congruent triangles will be congruent.